Dakshayani, Assistant Professor of Chemistry, Government College for Women. Today I am going to discuss about electrochemistry for the course BSc, subject chemistry, paper physical chemistry. This session contains liquid junction potential, salt bridge, and based on the liquid junction potential, problems to be solved. Liquid junction potential. In a concentration cell, when two solutions of the same or different electrolytes are brought into contact, a potential difference will be set up at the junction between them because of ionic transference. Potential of this kind are called liquid junction potential or diffusion potentials. Consider a simplest case in which junction is formed between the two solutions of the same univalent electrolyte concentration, that is C1 and C2. Here I have given an example for KCl. Here, so that is either side of those electrolytes are different in the concentration. Because of that, then there will be a difference in the concentration, then only there will be the possibility of generation of, that is the liquid junction. That is, when you kept a diaphragm, porous diaphragm in between that, so then there will be a liquid junction potential at the either side with respect to electrolyte. Here KCl, it is entirely different concentration, even though it is a KCl there, that is a C1 and C2. So when that is the 1 Faraday of, that is electricity, is passed into that, into the electrolytic cell, the cation or an anion, for example, if it is a transport number of K plus ion, move from, that is the cell 1 to cell 2, like that only in the opposite direction, that is the same Cl, that will be transfer from C2 to C1. Then that's whatever that will be a difference in the transference of these two ions, that will be depending on the conductivity, or that will be a velocity of that one, or what we called as a movement of one this transference ions. So if it is a K plus and Cl minus, whatever that will be, the conductivity of these two ions or that will be in the same, then there is no liquid junction potential that will be developed, or that this liquid junction developed due to the difference in the transference of the cation and anion. So that if it is both the conductance that will be a same, then there is no liquid junction potential, or that liquid junction potential that will be very, very small. Therefore, EMF of that whole cell depending on only a electrode potential in difference. If the change in the energy, if the electricity is passed through that, then it is equal to the whatever the transference of, that is K plus or Cl minus ion from one side to other side. So then the potential that will be developed, then the change in the free energy during that chemical reaction, then delta G is equal to N minus N into L. N is the Faraday of the electricity which is passed from that one cell to another one through transference of these ions which carry the current in it. Therefore, that is delta G is equal to minus NFE, that one. So here you go for that is a E is equal to, that is the change in the EMF, that is equal to delta G, change in the free energy on the cell. Then you substitute that one right hand and left hand activities by using the Nernst relationship. Then T plus the RT ln of A2 by A1 activity plus T of RT ln of A minus 1. This will be the equations from the Van 't Hoff reaction isotherm. From that you are going to get that delta G change in the free energy, then it is a summation of that is a EL, transference of the anion and the transference of the cation. It means that is whatever that will be a liquid junction potential depending on the magnitude of the transference of the cation and also the anion. Therefore, delta G is equal to T naught RT ln of A2 by A1 plus T minus RT ln of A1 by A2, which is the transference of positive, that is a K plus ion, and which is the transference of, that will be a Cl minus ion here. So therefore, that is a liquid junction potential E is equal to here, that is the minus of T plus RTF into ln of A2 by A1 plus RT by F into ln of A2 by A1 here. So since further T plus and T minus is equal to unity, it follows that 1 minus T plus equal to T minus. Thus substituting that one into that relationship, then EL, which is equal to T plus of RT by F ln of A2 by A1 plus 1 minus T plus into RT by F by ln of A2 by A1. Then EL, which is equal to minus of T plus RT by ln of A2 by minus of, that will be a T plus into RT by F ln of A2 by A1 plus RTF ln of A2 by A1. So overall, that's rearrangement, that is EL, that is the liquid junction potential, which is equal to minus 2T RT by ln of A2 by A1 plus RTF ln of A2 by A1. Here it means that mean activity of A1, and that will be A2 becomes A1 and A2. Then EL, which is equal to minus 2 RT 2 plus RT by F ln of A2 by A1 plus RT ln of A2 by A1. Here whatever the transfer, that is ionic activity of negative, and it is an anion, that is A2 by A1 becomes A2 by A1. Then this equations become EL is equal to 1 minus 2 into T plus into RT ln of A2 by A1. Since that is 1 minus T plus is equal to T, or T plus of, that is the T minus, which is giving rise to E cell. So that this must be expressed in the alternative form, that is EL is equal to T minus of T plus RT by F ln of A2 by A1. So that is whatever the liquid junction potential depending on the transference of number of, that will be of the cell. Therefore, if it is T minus equal to T plus, it means that transference of, that is T minus ions to the positive and positive T plus ions to the T minus. Then what happens to that? The liquid potential will be 0. If it is like that, the liquid junction potential is 0 or negligibly small. If the transparent number of cation is greater than that of the anion, it means that T plus is greater than T minus. Then LPG will be negative. LPG means that is the liquid potential junction or liquid junction potential will be negative, and if the reverse is the T minus greater than T plus, then liquid junction potential will be positive and will add the EMF of the cell. Next we go for the salt bridge. It is an inverted U2 containing saturated solution of some of the electrolytes such as sodium potassium chloride, potassium nitrate, ammonium nitrate, which does not undergo any chemical change during the process. The saturated solution is generally taken in agar-agar jelly or gelatin. For example, if it is required to know that EMF of the cell exclusive of the liquid junction potential, when you use a salt bridge table, that is X is the concentration of that will be a KCl, it is there as the increasing at 0.2 to 3.5, the EMF of the cell that will be decreases. As the KCl concentration increases, the salt bridge concentration increases, then EMF of that cell is negative. It means that will be a decrease in nature. So that we know that's the uses of salt bridge here. This salt bridge, it completes the internal circuit. They vanish liquid junction potential by equalizing the speed of ion. Nowadays, the liquid junction potential can be determined by the difference of each cell with and without transference. So here, that is whatever that will be in the aqueous solutions, if especially those solutions which contain mercury, or that will be a silver chloride or a mercury or an thallium, like that kind of that, where we are not able to use a potassium chloride as in a salt bridge here, because of that will be this potassium chloride easily reduces under those conditions. Therefore, instead of potassium chloride, we are going to use the ammonium nitrate or a potassium nitrate or ammonium nitrate salt bridge. We are going to use it in the such a condition. So, if it is an non-aqueous solutions, then you must know about that will be some of that lead acetate, potassium iodide that will be in the methanol, and sodium thiosulfate in the ethanol. You can use it for the preparations of that will be a liquid bridge. I mean to say, that is the electrolytic solutions. Then you have to use the corresponding salt bridge for that. So yeah, that salt bridge, it is they complete the internal circuit and they vanish the liquid junction potential by passing the speed of ion. And also nowadays the liquid junction potential can be determined by the difference in with and without transference number. So it is a problem will be there. Let's calculate the liquid junction potential at 25 degrees centigrade between two solutions of HCl having mean ionic activities of 0.01 and 0.01 respectively. The transference number of H plus ions, that is T minus this HCl, may be written as 0.83. So here the solutions in this case, that is the transferent number of, there will be a T plus and the T minus. T plus is equal to 0.83, T minus is equal to 0.17. Once you know that a transference of any one of the ion, it easily calculate the other. So here A1 is equal to 0.01, A2 is equal to 0.001. Then by using Nernst heat relationship, that will be temperature constant is there, or Nernst relationship, That's EL is equal to T minus T plus into RT of F into ln of A2 by A. And we substitute those values in that, it becomes 0.039 volts at 25 degrees centigrade. For the other one example, calculate the liquid junction potential associated with the following cell. So if it is AgCl, that will be associated with this a different concentration of then what happens to that one. And also the Ag cell, if transference of H plus ion 0.83. So solutions in this case, T plus is equal to 0.83 already given. So that T is equal to 1 minus T plus. So we have to get an T minus 0.197, the transferent of both positive and the negative. Then E T minus is equal to T minus minus of T plus RT over A2 by A1, which is equal to T minus T plus into RT by F into ln of, that is a mean ionic activity, and at the activity coefficient, then nu 2 M2 or nu 1 M1. So substituting all these values that is given to you, then you have to get a 0.05 volts or 50 million volts. These are the references what I study for the preparation of study material.